Hi, Sarah.
Hi, how are you?
I'm good. How are you doing tonight?
Pretty well.
So, what are you working on in class?
um, right now we're doing like basic graphing.
Okay.
So,
Graphing of the
yeah.
10 elementary functions, or?
Yeah, but so far we've only done like what we've been reviewing is factoring and then like slope-intercept form,
Okay.
basically.
Okay. That's funny. I was working on factoring with David earlier today.
It's important.
Well, it is. I
Paying
told him
attention.
that, boy, if you want to practice something, practice your factoring. You got to do it an awful lot. Um, so, what would you like to do tonight?
Um, Maybe some more SAT or ACT practice.
Okay. I got the SAT folder up here, and looks like we got through number 14, page 282. I don't know that there's a whole lot of difference between SAT and ACT. However, when you get to the point in time where you're taking one or the other in the near future, that's what we should work on.
Okay. Yeah, I have SAT on February 7th.
Okay, that's what we should be working on.
So.
Are you you're a junior, right?
Yeah.
Now, are you going to take the subject math at all?
What do you, like, wait.
Well, there's the standard SAT, and then there's the
Yeah.
subject, various subjects. You can take subject biology, subject chemistry, subject math, and there's two different levels of math that you can take. So it kind of depends on what college you're applying to and what you plan on majoring in. If you're going to go into engineering or something, then it would probably be a good idea, or some kind of science, might be a good idea for you to consider taking one of those at least, level 1 or level 2. Especially you're pretty good at math, so you should do reasonably well on them. The difference between the subject math and the SAT regular is pretty much all algebra and geometry. Subject math is pre-calc and trig. That's the difference. So by the end of this year, you will have finished your pre-calc and trig, and you'll probably be in as good a shape to take the subject math as ever. So you may not want to take it this spring, but you might want to think about taking it next fall.
Yeah, okay, I'll have to talk to my counselor about that. I didn't know that was a thing.
Yeah. All right.
Okay.
Let's see. Let's look at 15.
Okay, so wouldn't you just find like wait actually
In order to get its percent increase, you're going to need to know what its height was at year 6 and what its height is at year 9.
so you okay. So it'd be like 25 to 100?
Uh-huh.
And so 25%?
No. If you go 25 to, always remember that when they talk about percent increase or percent decrease, they're talking about relative to the original. So if we started at 25 and we went to 100, how much did we gain?
75 feet.
75, and we always divide by the original, not by the new. By that I mean, you understand how?
Yeah, because like 100% increase would be like going up by 1.
Right, okay. Now, let's say we go from 100 to 120. What percent increase is that?
105.
No, what percent increase is this? First of all, what's the absolute increase?
20.
Always divide by the starting.
Okay, so then you get 2%?
Well, it's 0.2, which
Yeah.
is 20%.
Okay.
Okay?
Okay.
Okay, what if we go from 100 to 75? What percent decrease is it?
Well, you're going down by 25, and then you divide that by 100, so 0.25, then it would be 25% decrease.
You got it. And that's the only two ways you can go, up or down. So, hold on a moment. Let me get this out of the way. All right, number 16.
Oh my goodness.
What's that?
Oh, no, just I don't remember how to find the formula this one.
Okay. One of the differences between the SAT and the ACT is
Yeah.
SAT gives you all of the pertinent formulas at the beginning question. In other words, if I pull up page 1, notice this little box here. So, what's the volume for a right cylinder? In other words, you don't have to memorize these for the SAT. You do for the ACT. Unfortunately, you definitely need to know, you may not need to know this one, but you need to know pretty much all the others by heart. The ACT will not give these to you. The SAT does. So what's the volume for a right cylinder?
Pi r squared times height.
So the volume of this right cylinder is pi r squared times the height. So let's substitute. What's r?
So r is pi x.
What's h?
2x.
Now, before we simplify that, we may or may not want to simplify that. Let's look, they're saying this is the volume of one of these, A through E has this same volume. Well, let's examine A, and that's all we can really do is examine each of them until we find this result. Okay? What is a cylinder with radius 2x and height pi x would be? In other words, let's say A is this, so that volume would be what?
Wait, so you'd have pi, yeah.
What's R?
2x squared and x, pi x. Pi x, not
The
x.
question is that the same number as this?
Maybe. Would you have to solve it out?
No, we don't really need to solve it out. Notice that up here we've got a pi times a pi squared. That's pi cubed. There's not going to be very many numbers that are going to equal pi cubed. If we don't get a pi cubed in this answer, it's not equal to that.
Okay.
This gives us a pi squared. So A is not it. Let's examine B. A cube with edge 2 pi x. What would the volume of a cube be? This you should know without me having to pull up that other table. What's the volume of that thing?
Side 1 times the length times width times height.
Okay, so a cube with edge 2 pi x has what kind of volume?
Cubed, it would be 2 pi x times 3.
Okay, well, that's promising. We've got a pi cubed now, right?
Yeah.
And we got a 2 cubed, which is 8. Is there 2 cubed up here?
No, there's not.
That's not right. A cylinder with radius 2 pi x and height x.
Yeah, so B would be pi times 2 pi x cubed. Or squared, sorry.
No, it's cubed.
Times, oh, it is
No,
cubed?
excuse me. I was getting ahead of myself. It is squared times x. Okay? Again, this is promising because I see a pi cubed and I see a 2 squared. Well, I don't see a 2 squared up here. That's not right. D. A rectangular solid with these 3 sides. Is that going to work? We can tell instantly whether it'll work or it won't.
No, I don't think so.
No, because we're going to have a pi squared, right?
Yeah.
We're not going to have a pi cubed. So, we're done with the problem. We answer E and we go on. But, just so you see that E works, and in reality, you really would be done at this point. You'd answer E and you would go on. You don't want to spend the time proving that E is the right answer. However, in training, a rectangular solid, what would the volume of that be?
The 3 sides multiplied by each other.
So pi x times 2 pi x times pi x. Notice that that whole thing is 2 pi cubed x cubed, which is what that is also. Okay? Now, that's probably one of the hardest problems you're going to run into, primarily because it took us so long. I mean, we knew exactly what we were doing, and it still was a 2 or 3 minute problem, and you only have about a minute to do each of these problems. So, that it's a perfect example of why you better be ahead of your pace when you get to the harder problems, because you need more time on the harder problems. There was no question we were going to get that problem either. So that previous problem is a great example of where you do not want to be guessing on this problem. I mean, as long as you know what the volumes of each of these 5 answers, the formulas for what they are, you're going to get this problem right 100% of the time as long as you spend enough time on it.
Yeah.
So this is not the kind of problem. If I ran into this first time through the test, I would definitely spend 5 minutes on it if I had to, because I know that that 5 minutes is well worth spent. In other words, it's not the kind of problem where I'm not sure if I'm doing it right. in which case I'm not going to spend 5 minutes on it. Alright, we got 3a plus 3 times b plus 1 equals c. What is b plus 1 equal to?
Would you just solve for b plus 1?
Yes.
Okay.
What's the next line?
Subtract 3a, so 3 times b plus 1 equals c minus 3a, and then divide that all by 3.
What's the answer?
So c over 3 minus a.
Yeah. Good. And there are, as we've seen, lots of problems like this where they don't really want you to solve for the individual variables. They want you to solve for some term, in this case b plus 1. In other words, we can't solve for a, b, and c here. There's no way to do it. There's 3 variables and there's only one equation. But they do make it particularly easy to solve for b plus 1 without being able to actually solve for b in terms of a number. It's my phone. I got a new phone over the Christmas holidays, and it whistles at me whenever I get a text or an email. I like it, kind of. I like that. It's funny. My dog goes really, her ears perk up when that happens.
Okay. Bounded by the x and y axis.
See, the shaded region in the figure above might be helpful if I showed the figure. I was trying to figure out the problem myself. Alright. This is almost a calculus problem. Just for your information, calculus, differential or integral calculus is all about the area between the curve and the axis. In other words, this would be a classic calculus problem. In other words, your regular geometry that you take, you have no way of figuring out what that area is, right?
Yeah.
That's what calculus is all about. All right.
Okay. Okay, so what does bounded mean? Bounded means...
Okay, this figure is bounded by the line y equal 3. This function, y equal f of x, y equals 0, the x-axis, and x equals 0, the y-axis. So there are four boundaries of that shaded area.
Okay.
And they're saying it's bounded by that, the x-axis, the y-axis, y equal 3, and the function. So there's some point, m comma n, that they want us to speculate on what might be true, or what has to be true. Does the x-coordinate have to be less than or equal to 3?
Yes. No. No, it does not.
But if I put it right there.
No.
Okay, so 1 is false. About 2. Does the y-coordinate, n, have to be greater than the x-coordinate, m?
Not necessarily.
No, that same area right there, the x-coordinate is very close to 4, the y-coordinate is less than 1. So actually anywhere in here, the x-coordinate would be bigger than the y-coordinate, right?
Yeah.
So 2 is definitely false. And if we look at our answers, we're done. We do not need to prove that 3 is correct because they don't have an answer that says none of them are true. In other words, based on their 5 answers, one of them has to be true, and we've just proved that 1 and 2 are false.
Cool.
So you could save 30 seconds by not trying to figure out number 3. But let's examine it anyway, just because we're in training mode here. F of m has to be greater than n. F of m means what?
F of m means the function when you put n into the
And m is the x-coordinate.
Yes.
So if I said, let's see, they say this is 4, I guess that makes, I don't know, 1, 2, 3, 4, 5. It's weird the way they've labeled this. But let's say, what is f of 4 according to this chart? What does f of 4 mean? If this function is f of x, what is f of 4?
Oh. 4?
0.
0.
In other words,
Y
it's
0.
the y value.
Oh.
So if x,
Sorry.
that's all right. If x is 4, then the y value is 0. If I said, what is f of 0, the y value would be 3. Okay?
Okay.
So they're saying that f of m has to be greater than or equal to n, the y-coordinate. Oh dear. Yeah, every place I look here, that's a true statement. Is it not?
I think
In other words,
so.
f of 4 was 0, but that's equal to 0, equal to the y-coordinate. In other words, no matter what I choose in this area, they're equal. But if I happen to choose f of whatever that number is, 1, f of 1 is 3, and that's equal. So the way I see it, that's always equal to that, which makes that statement true. F of m is the same thing as n in all cases. No matter what you choose, that's what f of m means, is it's the y-coordinate. It's f of x, or f of m. That's a bit of a tricky one there. But notice the tricky part was the part that we really didn't need to worry about. In other words, once we disproved 1 and 2, we're done with the problem based on the answers. So we don't actually need to figure out that third part. And that's critical. You want to make sure that you don't spend time on things that you don't need to. Especially difficult things that you don't need to.
Okay. Yeah.
19.
These ACT people are super tricky.
Yes, this is a little tricky, this problem. All of these, I've been noticing the last couple sessions, these problems are all relatively difficult. But that's good. That's what you need. We wouldn't want to be wasting your time doing all the easy ones.
Yeah. Okie dokie. X which is long. Oh my goodness. We did it last year. So a lumber company.
This is actually this is based in reality. This is actually the way you buy lumber. If you go to a lumber company and you want to buy 13-inch boards, you don't get 13-inch boards. You get boards that are between 12 and 15/16 and 13 and a 16. In other words, they're cut within that margin.
Okay. So if they sell a board that is X inches long. So weird. Okay. Would you just subtract it out from the difference?
This is kind of a logic problem. Let's examine each one. A, does that work?
Not really.
Well, it almost does.
Yeah,
but it doesn't have to be exactly 1/16. In other words, you actually could get a board that's exactly 13 inches. And then 13 minus 13 would be 0, and it's not equal to 1/16. So we're close here, but that's not exactly the way it is. Well, B clearly isn't right. If I add the actual dimension of the board to 13, I do not get 1/16. C, D, and E all are correct because they're all inequalities. In other words, we don't know how much the board measures. We just know that it's within 1/16 of 13 inches.
Yeah.
So which one is correct, C, D, or E?
E?
Yeah.
Because it has to be less than that. Yeah. Okay.
In other words, I could not have a 14-inch board. A 14-inch board would not fit there. It's off by more than a 16th inch.
Yeah. Okay. That makes sense.
Yeah. All right. Let's do one more. I hope. Oh boy, I hope I have time for this one. This is a good problem. I don't want to miss it. Yeah, I got 2 minutes. Unfortunately, I got a 7 o'clock, but this is kind of a common theme in both ACT and SAT, this type of problem. So you want to make sure you get this.
Okay. Oh my goodness.
This is a sequence. Difference between sequence and series is sequence is just a bunch of numbers separated by a comma. Series is all those numbers added up. What's the first number in this sequence?
Negative 30.
Huh? What's the next number?
Negative 29. Okay.
If I add them all up, what are my last two numbers? Let me ask you this. How far do I have to go before, when I add them all up, they get to 0?
20 or 30?
Yes, that's the key understanding. If I add up every number in between this and this, I'm going to have 0.
Yeah. And then, so how many integers are in the set? Well, you don't know, because the sum of them is 66. So when you add them all together, you get 0.
Yeah, I'm trying to figure out what's going on here. I'm trying to figure out if they have a typo here. Because the next two digits would be 31. Consecutive even integers. digit is 28. Negative 28. I didn't read it right. Okay? However, it still means I got to go all the way to 30 to get to 0, right? What are the next What are the next two integers?
After 30, 32 and 34.
What do those add to?
Those add to 66.
There's my sequence of integers that add to 66. How many numbers are in that? How many integers are in that set?
So 15 and then another would be, no, not 14. So I don't want to keep you 33 because...
Perfect. Because of 0. In other words, there's 15 to get to 0. There's 15 more to get from 0 to 30, but there's also 0. So there's 31 to get to 30. 32, 33. Sarah, I got to run. I'll talk to you next week.
All right, awesome.
All right, bye-bye.
Thank you.
Well,